Now we're going to take a look at solving some trigonometric equations. And this first section kind of helps us to get our feet wet. And then in section 3.8, we'll go a little bit deeper. But for now, a lot of what we've learned in algebra will apply here. And that is when we're solving for a particular variable, we try to isolate the variable term, or in this case, not just the term, but the function that involves the variable. So let's take a look at example A. We want to solve each equation on the interval 0 to 2 pi. This means we want to find every solution within this interval, okay, which is, of course, one revolution around the circle. So obviously, or hopefully it's obvious that there would be infinitely many solutions if we didn't include these restrictions. But because we have the restrictions, then that's going to help us to come up with a finite solution set. Okay, so we've got 4 cosine squared theta minus 3 equals 0. Like I said, I'm going to isolate the function that has the variable. So we get 4 cosine squared theta equals 3, or cosine squared theta equals 3/4. Cosine theta then is going to be plus or minus the square root of 3/4. Okay, and then if I reduce that, we get cosine theta is equal to plus or minus square root 3/2. Okay, now we still need to know exactly what theta is. And this is where we stop and ask ourselves, okay, well, which quadrant are we talking about? This is not the same thing as the inverse function. We only have to consider those restrictions when the problem starts out with the inverse function. This is actually asking us, where's cosine theta equal to plus or minus square root 3/2? Well, of course, the reference angle for that is going to be pi over 3, or 30 degrees. Okay, so I know it happens over here at pi over 3. Okay, and cosine's positive there. Okay, but also cosine is positive in this last quadrant, which is going to have a reference of pi over 3. Okay, and if we're talking about thirds, then this is going to be 3 pi over 3, and this is going to be 6 pi over 3 by the time we wrap back around. So 6 pi over 3 minus pi over 3 is going to give me 5 pi over 3. Okay, but we're also interested in where it's negative. So we need to look in the second and third quadrants as well. And so the reference angle in both of those is still pi over 3. So that's going to give me 2 pi over 3 here and 4 pi over 3 here. Okay, and so our solution set is theta is equal to 2 pi over 3, 4 pi over 3, 5 pi over 3, and pi over 3, which I should have put first, but it really doesn't matter. So that is our solution set. Okay, let's look at C. We'll come back to B. We've got cosine root 2, or rather 3 root 2 times cosine theta. First thing I'm going to do is subtract 2 from both sides. So we get that that's equal to negative 3. And I can divide both sides by 3 root 2. So we get cosine theta equals minus 3 over 3 root 2. The 3's cancel, so we have negative 1 over root 2, or if we rationalize that, negative root 2 over root 2. And that should make us think about a reference angle of pi over 4. And so we need to think about where's cosine theta negative. And of course, cosine is negative in quadrants 2 and quadrant 3. We've got a reference of pi over 4, pi over 4. Okay, if we've got 4 pi over 4, okay, that's our 180 degrees, or pi, then the values of theta would be 3 pi over 4 and 5 pi over 4. All right, in this problem, we still want to solve for theta. And we've got cosine theta over 3 minus pi over 4 equals 1/2. Okay, well, we're taking or trying to find cosine of the difference of two angles. So I'm going to use those formulas, I believe, to try to help me out. Hopefully everything will work out fine for us. So I know that cosine of theta over 3 minus pi over 4 I can rewrite as cosine theta over 3 times cosine pi over 4 minus sine of theta over 3 sine, and that's going to be plus. So we get sine pi over 4 equals 1/2. Okay, well, fortunately, I know some of these values. I know cosine of pi over 4 is root 2 over 2. So we get cosine of theta over 3 times root 2 over 2 plus sine of theta over 3 times root 2 over 2 equals 1/2. Okay. The other thing I can do is go on and multiply through by 2. So I get root 2 times cosine of theta over 3 plus root 2 times sine of theta over 3 equals 1. When I multiplied by 2 throughout, then I was able to cancel these 2's that are on the bottom. Okay, and I see here where I can factor out a square root of 2. And of course, the next thing, since I factored that out, that I'm going to want to do is say cosine of theta over 3 plus sine of theta over 3 equals 1 over the square root of 2. Well, that still doesn't get me to where I need to be. I'm still trying to figure out what theta is. So when I look at this, I don't recognize anything, any identities or anything that would help me right away. But I know I need to get rid of, the cosine and sine. That's a problem for me right now since I don't have an identity that ties them together. One way that we might consider eliminating cosine and sine in a situation like this is to square both sides. Because when we square both sides, we're going to end up with a cosine squared term and a sine squared term. And of course, we know cosine squared theta plus sine squared theta equals 1. So what I'm going to do next is square both sides. Carefully and correctly. When I square the left side using, FOIL, if you need to do it that way, we get cosine squared theta over 3 plus 2 cosine theta over 3 sine theta over 3 plus sine squared theta over 3 equals 1/2. Okay, 1 over root 2 squared would be 1/2. Okay, um, and again, we got that just by using FOIL. I actually, if you need to, do cosine theta over 3 plus sine theta over 3 times cosine theta over 3 plus sine theta over 3. Okay, and then this is what you should get. Okay, but like I mentioned already, cosine squared plus sine squared equals 1. So I'm going to write this as 2 cosine theta over 3 sine theta over 3 plus 1 equals 1/2, or 2 cosine theta over 3 sine theta over 3 equals minus 1/2. Now, when we look at this, we need to stop and say, well, is there anything that we know of that's equal to 2 times cosine of an angle times sine of the same angle? Okay, and if you look at your formula sheet, hopefully you will recognize that this looks like our double angle formula. This looks like our double angle formula for uh, sine, 2 sine theta, where for us, our quote-unquote theta, or if I say it in terms of what's on your formula sheet, I believe we have alphas. So this is my alpha, okay? So I've got 2 cosine alpha sine alpha. That fits the formula, okay, for my double angle identity. So I can write this as 2 sine alpha, which in this case would be, I'm sorry, sine of 2 alpha, okay, where my alpha is theta over 3, okay. And so now we've got sine of 2 theta over 3 equals negative 1/2. Okay, so since we have sine of some angle, and it doesn't matter about the 2 theta over 3. I mean, don't let that part scare you right now. Is sine of some angle is equal to negative 1/2, okay? And what we need to know is which angle is that, okay? And so we know sine, whatever it is we're calling it, of an angle is equal to negative 1/2 when the angle is what? Minus pi over 6, or if we do it between 0 and 2 pi, it would be 11 pi over 6, okay, because sine is negative there, and also at 7 pi over 6, okay, still using those ever important reference angles. We know that sine of 30 degrees or sine of pi over 6 is 1/2, but I want to know about where do we get negative 1/2 for sine. And so of course that happens in quadrants 3 and 4. If I have a reference angle of pi over 6, this is going to be 12 pi over 6. This is my reference of pi over 6, and so that's how I get 11 pi over 6. On the other side, we'd have 6 pi over 6 plus pi over 6. That gives us 7 pi over 6. So that's the angle that gives me negative 1/2. So what I can say is 2 theta over 3 equals 7 pi over 6, and 2 theta over 3 equals 11 pi over 6. And so go on and solve now for theta. And we get 2 theta equals 3 times 7 pi over 6. Okay, of course, those are going to cancel out, and we get 7 pi over 2 right there. And if we divide by 2 on both sides, we get theta equals 7 pi over 4. Okay, over here, we've got same thing. 2 theta over 3 equals 11 pi over 6. So that's 2 theta equals 11 pi over 2 when we cancel things out. And if I divide by 2, I get theta equals 11 pi, over 4. Okay, but if we wanted our answer to be between 0 and 2 pi, we've already overshot 2 pi. That would have been 8 pi over 4. So the coterminal angle is 3 pi over 4. 11 pi minus 8 pi over 4 gives me 3 pi over 4. So my solution set would be theta equals 3 pi over 4 and 7 pi over 4. Lots to consider in that example. I'm sure there'll be a lot of questions.